Okay, so we made it to third normal form, and what we wound up with is a database that looks like this one, where we have the information scattered around in many tables with few columns and few rows. Now, that sometimes makes us sort of long back to the old days when we had first normal form and our information was conveniently stored all in a single table. Of course, the problem with that was we wound up with inconsistencies. So if we looked at what that student info looked like, we got, Debbie Dutton's name was misspelled here, and college composition was spelled competition here, that kind of stuff. So we have to get to third normal form to eliminate the possibility of inconsistencies in the data. Because if we're not in third normal form, we will have inconsistencies. So we put together a database that looks like this, and we wound up with the information scattered around among the student table and the major table, the course table, and the registration table. It would be nice to be back in the case where it was all in one convenient place. Well, we don't have to design our database in first normal form in order to get data in one convenient place. Instead, we design it in third normal form, and then we create a query that joins the tables back together and makes it look like they're all in one. So now we have a join like this, join for third normal form. I just gave it kind of a silly name. It joins the student, major, register, and course tables all together and outputs information from all four of those tables. And what we wind up with, let's run it, is data that looks like this. It looks like it was in first normal form. Here's our first normal form table. Let's look at that one. So take a look at these two outputs. Yeah, the columns are offset a little bit, but it's essentially the same information. In our join, we're able to join the tables back together and temporarily make it look like it's in first normal form, with one huge benefit. Since information technology in all of these records came from just the one table, major, this one cell right there, we are guaranteed that they are absolutely consistent because they came out of only one table. In student info, information technology wound up getting spelled differently, like this and that, so we got inconsistencies. But by creating a query to join the tables together and getting a result that looks like first normal form, we have the convenience of seeing the information all together, and this kind of query is often used in report generators and making lists for users to see and so on. While we get all the benefits of third normal form, meaning we have a nice consistent database. So we design them like this so that there's no inconsistencies. This is a good quality design. And then we write queries like this in order to knit the information temporarily back together with perfect consistency. So the idea of using joins is, the principal reason is to bring back the information that got scattered around in the tables because we moved into third normal form and bring it all together. Now, one other topic that's a little bit different is there ever a case when you would store a table denormalized, not in third normal form? And the answer is yes, but it's limited. The one place I use denormalized tables are, for example, to record invoices where the business has sold something to a customer. That's a one-time event where you sell something to somebody, and maybe they come back next week, you sell them something else. But what you want to do is save that event, that sale, exactly like it was forever. And for that purpose, I created a denormalized invoice table where when the sale is completed, I write a record into the invoice table with the customer name, address, city, state, zip, the name of the product, the cost, and all that kind of stuff. It's a big denormalized table because it pulls information in from customer and product and the sale table and that sort of thing. But it's a snapshot of a transaction that we want to preserve forever so that if we change one of our other tables, it won't accidentally change an invoice and sort of change history. So in history-style tables where you're recording an event, you're making a snapshot of it, you're writing it once and you'll never change it again, then denormalization matters and is a useful thing to do. So I create history tables denormalized, but not operational tables like student, major, and course, and so on. The transcript table in a real college system would be a write once, never read, and then read many times, never write it again, because you want a student's transcript to remain the same forever, no matter how you change your classes and credit hours and that kind of thing. You want a snapshot. So a transcript table would be denormalized. So tables that are write once, read many times, those are okay to be denormalized. There's also some limited cases where denormalization might be done for performance reasons, but those are quite rare. So to sum it up, we want to get to third normal form where we have no inconsistency in the data, and then we write views like this one to knit it back together so we can see the data in a convenient way.